Yeah, so I want to start with a little story, or just a saying really, which is apparently something that originally said by Wayne Gretzky. I think he does sports, but it was repeated many times by the late Steve Jobs, and people say it really informed his view of how Apple as a company works. And that's the saying is, you should skate where the puck will be. So what that means, right, is in this sport that this guy played, you want to go to where the objective is going to be when you get there. You don't want to chase after it and constantly be playing catch up. So I think this is a powerful metaphor and a powerful philosophy. I think it's especially applicable to the future of JavaScript. So on a lighter note, the reason that my talk is titled this is because something like a year ago, this amazing graphic showed up on Twitter where I believe somebody is like assaulting a compiler engineer as they leave their office in Mountain View probably, and they're saying, please implement string.prototype that starts with ES6 is nigh. So the first thing I immediately did is I went out and bought the domain name es6isnigh.com, and I've only found a use for it today when I uploaded all my slides there this morning. But the takeaway from this image is we don't have fucking string.prototype that starts with. We're not only like playing catch up with the puck, like the puck is skating out way far ahead of us. JavaScript is not actually that much fun. As much as you may have, as much as you may enjoy yourself, it's a little bit of Stockholm syndrome. All right. So this is me. Just to give you some background, I do a lot of open source in JavaScript. I'm really passionate about that. I put a lot of stuff on NPM as node packages. So a lot of people in the node community have a rather unhappy perspective on ES6, and I hope to kind of bring them together. That's like my life ambition, along with getting Node working on Windows. But we'll see how that works. I just want to let you know that I'm not like one of those crazy browser guys who thinks that the language is going to save them from everything. I've also started this Twitter account, ES Discuss. Now, if you don't know, ES Discuss is the mailing list where the committee and others who are in charge of determining the future of JavaScript discuss like the next version of JavaScript. And of course, it's full of dense technical language and arguments and things. And so what I do is like every 2 or 3 days, I go through my inbox and I summarize the latest things that have been going on this mailing list in 140 characters. I would say or less, but I pretty consistently hit the limit exactly. So that, I think, if you're interested in the future, and I think you should be, you might want to subscribe to that. It's a little bit of minutia, but you can always just not click the link. All right, so let's get into the meat of this. Like, where do we come from, right? So a lot of people don't realize, but there was a version of JavaScript before, even the version we got in '96. It was called ECMAScript 1. ECMAScript is the trademark-free term for JavaScript. Like Kleenex and tissue paper or whatever. So in AS1 we didn't have such basics as try-catch or do-while or switch or regular expressions, these kind of things that are fairly integral to your programming today. So we kind of saw that this was necessary and released a new version of the language, which everybody has access to these days, which has those. And then we have ES3 to ES5. Now this transition is still ongoing. Node has full support. All the browsers IE9 and above, and by that I mean IE9 and everything else, have full support. And this brought things that are a little more subtle, but also super important. Things like accessors, getters and setters, strict mode, which is it's about enabling you to have static scoping, saying that when you say a variable name, you actually know where it comes from, and the compiler knows where it comes from, instead of it just being arbitrarily somewhere in a with or an eval or various crazy things that can go on. You get object reflection APIs to really dig into what's going on under the covers of your objects. And of course you get JSON and array extras and those things that make your life nicer. And now we have ES5 to ES6, and that transition is currently ongoing. The spec is scheduled to be finished by end of 2013. But there's implementations in browsers already, and we'll talk about that a little bit. But I did want to notice, like looking at this history, there's a pretty clear distinction you can draw between two types of features, right? So these features are for your comfort, right? They're to make your life less miserable. Things like string.prototype starts with, right? The do while and switch. Like you could do those with while and change if statements. And even strict mode, like it's a little borderline, but you know, if you write your code the right way, you won't run into the problems that strict mode causes. I mean, if you're perfect, basically. Strict mode gets rid of. And JSON and array extras, right? There are implementations of those in JavaScript. But then all the other features, these are magic, okay? You just can't do this without a new version of the language. Try catch, regular expressions. I mean, you can write a regex parser, but you can also write a C compiler in JavaScript. Like, it's not... You know, accessors, this gives you completely new ways to manipulate objects. And object reflection, you could never look into the innards of what's going on in, like, their non-writable properties in the DOM, for example. Distinction as we cover the features in ES6. Because, you know, there's two aspects of making it better. There's comfort, you know, making your life less miserable, and there's the magic, which is allowing you to do more things. And then the last question, before we dive into things, is why, right? We get a lot of this. We have, and to me, this was always obvious. It's like, well, newer is better, right? Like 6 is greater than 5, so of course, you know. But I had a really good discussion at LXJS with Michael, who's on the, you know, a little bit leery of the ES6 side, shall we say. And, you know, what he kind of communicated to me is that the concern is, like, it would be nice just to have something finished and build on top of that. Like, have a stable base. You know, ES5 is fine, and Node is fine, and, like, Node will get to 1.0 and it'll be done, and we'll build things on top of Node, and we'll be good. And then we don't have to fragment the community. You know, we don't have, like, this issue where people are publishing things in other languages, like CoffeeScript or I don't know, type. I mean, like, you can always look at somebody's source code and know it's the same version of the language. So, you know, this is a pretty valid argument, and it makes a lot of sense, but it makes a lot of sense in the short term. And the argument that I found, wow, that just went all wrong. The argument that I found most compelling was by Brendan Eich on Hacker News. Now, if you follow Brendan Eich on Hacker News, he gets into a lot of arguments, and it's really fun to watch. But he had this really great post, and his key thesis was that stagnation on the web is a social ill, right? And what he means by this is that it costs us, okay? And we know this. We know this from most prominently the IE6 days, okay, where the web was stuck in this perpetual limbo of never evolving features, but everybody had the same browser. And also we know that today from the Android 2.x, right? We're still stuck supporting that browser, and we're stagnated there, and Google, like, is powerless to do things about it because carriers and reasons. So, right, and so developers get unhappy, and they do crazy things like CoffeeScript. But even worse, right, is large corporations see this as an opportunity. And by large corporations, I of course mean corporations who don't want to be evil. So of course, like back in the day, we would think of that as Microsoft, right? And maybe they said they didn't. I don't know. People thought they were evil at some point. And what they did is they did Silverlight, right? And that was originally called WPF Everywhere. Their Windows application programming was going to be everywhere, like the web. So you were going to code C# in your web browser because JavaScript sucks so much. But even today, we've got people who say JavaScript is unfixable. Like they publish memos, and they say, we cannot fix JavaScript, we need a new language, a new VM, and we're going to use our rendering engine and our browser's clout to create a new language. I think they called it Visual GB Script. No, actually they called it Dart. That is proprietary and is just like, now you've got this new language competing for JavaScript because we think JavaScript sucks so much. And of course you've got the other project, Knackle, I believe that are otherwise known as ActiveG. So you run native code in the browser. So now you're putting C++ in the browser, from my understanding. And the idea is that people will start using these because they can move faster than when they're working in a language from 1998, right? Which is what ES3 is. And even a language from, I don't know, like 2005. I don't even remember exactly when ES5 is. But eventually we're going to run out of stagnation is going to cause these problems. And Brennan's argument, and I strongly agree with him, is this is not acceptable, right? We build a beautiful, amazing community with a ton of amazing code, and starting over means we have to rebuild that, relearn all these lessons, and do everything like right this time, right? And I'm sure you've all read the Joel on Software blog post, or the great rewrite, right? You don't want to actually do that. You're going to lose all that accumulated knowledge and bug fixes, and not to mention in our case, community and code reuse. So you get that and the developer brain power, and it just all gets thrown away, and for no reason, because we couldn't move forward fast enough. So finally, and this is just me, like, say what you fucking mean, okay? Don't say, like, function.prototype equals this, but set the constructor because this, and don't, like, create modules out of crazy immediately invoked functions, but sometimes you use a define, which is a keyword from a special library, but there's a standard, but it's really a standard hosted on GitHub, and then you use callbacks for control flow because there's no other way, and then you iterate over objects using object.keys array for each, and then you do like r equal to r or default, except for if the argument could possibly be like a falsy value, like 0, and you need to use like equals equals undefined, or maybe equals equals null because you think that null is a valid way of filling out defaults. What the fuck, guys? Say what you mean. So ECMAScript 6 gives us two things. It gives us comfort and magic, and the comfort is really what I'm addressing here. It's nice to be able to write code that isn't about the idiosyncrasies of your language that you've really started enjoying because of your Stockholm syndrome. But no, I actually want to solve engineering problems. Okay, maybe it's just me. So all right, into the thick of things, right? So the biggest thing that I think people haven't had communicated to them about ECMAScript 6 is this philosophy called one JavaScript. And what this means, in a nutshell, is that all existing code, all ES5 code, is ES6 code, and the meaning will not change. You get a new browser, it has ES6, nothing will change with your code, it will not break. And this is, of course, kind of obvious, they're not going to break the web. But the alternative, and this is what they were considering for many years, is that there'd be like two modes, right? And we might call them, say, like Python 2 and Python 3. Or in their case, like application / ES6, script type equals. But I mean, that's not what we want. We want the same language, just better. As a consequence, this means no backwards incompatibility. That sounds great, right? But that also means no fixes. So, type of null is always going to equal object. We can't fix that. That would break the web, right? For-in is always going to be broken. We can't fix that. That would break the web. We need to have one JavaScript. Things stay the same. Semantics stay the same. So ES6 is purely additive, right? It's not going to take away your toys. It's not going to reform them. It's not going to... But this is actually a good thing. All right, so what are the features that we're going to see in ES6? Well, I've categorized them into three categories. And then, two of them are the comfort and magic. And the other one, which is my favorite because of the drawing I created for it, is, so this is us right now. We're cows, right? And we're slowly winding down this path. And we slowly have created this path through the mountains where we're like, oh, well, the way to do default arguments is arg equals arg or default. And the way to do classes is to set up this crazy problem thing, except for if you don't have object create, you need to use new, but then you need to make sure. So we've paved this kind of shoddy cow path. What they're doing, well, no, we haven't paved it. What they're doing is they're paving it, right? They're going to create this nice paved cow path for the cows to walk down, with all these pretty bushes and a resort nearby. And these are the features that to me pave the cow path. So parameter defaults, like you can actually use the parameter equals this, and it will have a default value. They give you arrow functions so that you can actually use array.map and filter and so on without wanting to claw your eyes out because you typed function and return and braces and wish you could use CoffeeScript, but then everybody would make fun of you. So. And they give you classes, right? And as John Paul said, in the last talk, it's exactly what we have now. It's just sugar, and it expresses what the heck you mean instead of the internals of JavaScript. And finally, modules. Now, I have to admit, modules are not fully baked right now, but you have to, if you just step away for a moment, the system we have works really well, in Node especially, but you've cobbled it together out of closures that are inserted behind the scenes, and synchronous file I/O, and mutable like exports objects, but sometimes you use module exports, and it's not statically analyzable. So if you want to use a module in the browser, you have to make sure you never can like create a module ID out of a string by using a plus sign. Like it could be better. And I'm not going to talk about how it's going to be better because honestly, I don't think the committee has quite grasped what the community needs and also wants to solve their problems. But it is a cow path that's going to be paving. All right, on to the stuff I am going to talk about. Because this stuff is just like paving the cow paths, right? You already know how to do this. So right now, yeah, this is JavaScript. This is the bed we've made and that we lay in. And it's not very comfortable. But this is ES6, right? You get a nice plushy hotel, maybe a lamp, a picture of a white square. And these are the features that are make your experience more comfortable. So we have better object literals, rest, spread, block scoping. I'm going to talk about that in depth. Const, destructuring, sets and maps and iteration. So I'm going to skip over a lot of these because you already see them in CoffeeScript, but I'm going to talk about them, and I'm especially going to talk about block scoping because that's a big change that I don't think people I think if people knew exactly how cool it was, they would be clamoring for it. All right, the final category. Right, is currently this is JavaScript. We have all this technology. We have function that does everything. It's super powerful, right? We can build everything out of it, including giant space satellites. I'm sure some of those are on JavaScript, maybe. But what we really need, right, to move forward and to skate where the puck will be, is magic. So there's a lot of magic, and some of the cool things that I'm not going to talk about in depth are proper tail calls if you're a functional programmer, or if you want to write a compiled JavaScript language that's functional. That's going to work now. Binary data, if you want to do graphics processing that doesn't take up like 32 bytes for a Boolean, 32 bytes for 1 bit. They have that. They fixed Unicode. Okay, so you couldn't do emoji in JavaScript. In ES6 you can. Weak sets and maps, they're really cool and really useful, but there's good blog posts explaining them. So I want to talk about the things not everybody knows about. All right, let's quickly skip through the comfort stuff, right? Oh my god, we skipped to the end of my freaking talk. All right. So, comfort. Magic. Comfort, right. Better object literals, right? Okay. You can declare methods like this without the function. I'm sure you've done this before and been like, why doesn't this work? Oh, I forgot the colon function. Yay! You can declare objects like this without the colon, the same variable. All right, great news. Right? Our experience is better. Rest and spread. Remember the arguments object? Remember array.prototype.slice.call arguments? Remember how much that sucks? Yeah, okay, we're getting rid of that. Okay, so we're just going to say that you put a ... before that thing, and you get an actual array that's the rest of the parameters soaked up. You can call functions like math.max that accept a variable number of arguments with an array now, just by spreading it out over the function call. You can intersperse those arrays with actual arguments. You can do constructor calls with apply, essentially, right? You can do an array of arguments and put it in a constructor. That's not actually possible right now, except for, I think, with some crazy eval shenanigans. You can do things like array.push. It's another common use case where you have an array of things you want to put onto the array, but you got to use apply. So we got rid of apply and call, and we got rid of array.prototype.slice.call arguments. And that's nice. A little bit more spread, so we can create arrays using spread, right? We can put arrays together. And this is a big one. If you have something that's iterable, like say a node list, you can just turn it into an array with that little bracket, ... thingy, and bracket. And now you can use all your array methods, like for each. Thank God. It's been a while. Why did that take so long? Destructuring, right? You may have seen this in CoffeeScript or other languages. You can now swap variables without intermediates. You can return multiple values from a function. This is especially cool, use cases, regular expressions. Nobody cares about that first parameter. You get this array, and you're like, I know what I want. I want these pieces of the regular expression. I don't want that whole string match. And you can pull off pieces of an array, and of course, it works with things that aren't just arrays, like node lists, right? And it works with not just arrays, it works with objects too. So you can just pull pieces out of an object without repeating yourself, like left hand, right hand. And you can do this to arbitrary depth, and you can mix this with array syntax. Finally, you can use it in function declarations. So, we say, oh, I want an options object, and it should have 2 pieces. And instead of pulling those out manually, you just grab them, right? And you can do things like destructure the rest of the argument or an array that follows. I especially like the catch example here. I think it's really clever. Often you just care about the message of the exception. Well, now you just have to say, all I care about is the message. All right, so that was a warm-up, right? You've seen that stuff in CoffeeScript. And you're like, I wish I could use that, but everybody would make fun of me. So block scoping. So here's a function that uses this new let keyword. And the idea here is that we no longer have this hoisting problem. When we use braces, like in every other language, the variable falls out of scope when you go outside those braces. So we can shadow the declaration of log, but then that doesn't take over log for the rest of the function, right? It still means what it did outside. All right, so this is cool, and this brings some sanity to the proceedings. But where does it really help us? Well, it has a lot of cool features, actually. So 5 refactorings later, we've gone in circles a bunch of times, and we end up with this version of the function. And we don't have unit tests, because... so we're like, oh, well, I'm going to run this, and it's probably going to work fine. No, it turns out that now you will actually get an error. Instead of undefined is not a function, you'll get, oh, you used a let before you declared it. You're not allowed to do that anymore if you use let instead of var. So that's super awesome. Unfortunately, it's a runtime error instead of a static analysis error, but what can you do? Similarly, you can't double declare, right? So 10 refactorings have gone by and you're like, oh, why don't I just move this inside there? Oh, that's why. So yeah, that's the idea. And finally, it fixes the usual closure problem. John Paul talked about this, right? You can actually use let in the body of a for loop, and it will mean what you want it to mean. It won't change and get hoisted to the top level, and then you'll be like, oh, it's always the last element. And you won't create a bunch of temporary variables. You're like, oh, I have 2 for loops in a row, and now JS Hint is yelling at me because I declared I twice. Finally, we've got block scoping of functions. So this actually behaves inconsistently in all major browsers right now. Whether that function will be defined, or whether it will throw a syntax error, or whether it will persist outside the block, it's not actually specified. It's not allowed by the spec actually, but many implementations have something. So now, if you put the function inside a block, they'll behave like let, and there you go. We also get const. It has the same semantics as let, but you can't change it. So you get an actual error when you reassign it. It's interesting, because when I was doing my slides with all these examples, and all my lets, because let is awesome and var sucks, I was like, actually, I could just use const for almost all these. Something to think about. That's kind of how you program these days. Also, it just prevents you from being stupid. You can't create a constant that doesn't have a value. So this is nice. All right, let's fix another big problem. Iteration, right? Iterating over arrays with for in doesn't work. Array.for each, that works. Well, okay, wouldn't it be nice if we had an actual loop syntax for arrays that worked? Yeah. So you can do this now for arrays, for these set objects, and for maps. And you can actually do custom iterators as well. That's it for comfort. Let's go on to magic really quickly. So these are the magic things that I like the most. So template strings. Now you can do string interpolation without that plus sign. Yes! You can do multi-line strings without slashes at the end, or joining an array, or wanting to kill yourself. Yes! But it's even more powerful than this, right? Because this is just okay, cool, whatever. You got some backticks. Actually, it solves the entire encoding escaping problem. So you can put a little name of an identifier in front of the backtick, and it will apply that function in such a way that you get enough data to usefully do transformations on the variables you pass in. So this function, this save HTML function, there's a paper some people published on how to detect whether you're in a query string or an attribute or a JavaScript attribute or just HTML body, and they do the right thing in every place, right? They percent encode it for the query string, the HTML encode it for the HTML, they do extra escaping so that you can't insert malicious scripts. It's super amazing. So this solves everything. This solves SQL injection, this solves, this is a general purpose solution to format strings sucking. So just because you're oh, why don't we just do string.format, that doesn't solve things, right? You can still SQL inject with that. And somebody's going to have to build a custom solution that like wraps string.prototype format so you don't SQL inject, but then they'll do it for safe HTML. Like, it's no good. You need something more powerful. All right, next up, symbols. So here's some current JavaScript code, right? And what we're trying to do here is we're trying to create a private variable. So of course we use our favorite friend, the underscore, which totally is a clear way of signaling you should never touch this function, because everybody who has ever worked with third-party code has never touched an underscore function. So like when that code that's using the underscore, that has the underscore function, wants to say like, oh, I'm going to refactor this implementation, right? Well, yeah, they can just delete that underscore function. Nobody's using it. Not so true. So basically, when you create an underscore function in your library, and you're like, this is private, don't touch it. Yeah, that's not really private. Once people start depending on it, you can't get rid of it, and it's there forever, and you can never refactor your code. Great. There's also the issue where if somebody derived from this class, and they're like, oh, I want a Twitter API key to be stored there, they're going to overwrite the Amazon S3 API key. So there's this namespace collision issue. And so you can solve this today by moving to closures, right? So you have like actual private variables, and Crockford talks about this at length in the good parts. But this makes VM writers hate you. So I was at JSConf.eu and talking to the Dart team, or the 8 team, and also the Chocolate team, and they're like, don't do that. Don't, no. Because this allocates memory for every object, for every method in that object. It's a really drastic demonstration of this with JS DOM recently, where some people suddenly upgraded a point version that I merged a pull request and they're getting out of memory errors. Because every time you created a DOM node, we get the style, and so for every CSS property, there'd be like a closure, and on every DOM node, it's bad. Moved to prototype, solved everything. Yeah. All right, so here's the solution. Is these new objects called symbols. So we add one piece of extra semantics, which is that when you use brackets to access an object, you can put symbols in there as well, not just strings. So now, the thing is, without access to that symbol object, nobody else can get at those properties. So you can give them to other people if they want, like if they're writing plugins, say. But by default, nobody can touch them. So you can have actual privacy without sacrificing prototypal inheritance. Pretty nice. There's some sugar for this, right? This isn't quite finalized, but this is kind of where they're heading. So you just have to you don't have to type a new symbol and look at the guts. That's nice. And now we have this technology, we can implement custom iterators. So an iterator, it turns out, is just an object with a next method. So, and the way that you add it to an object is you add this iterator symbol, and you say, oh, I'm going to store in the iterator symbol, like this custom iterator factory. So now I can iterate over my custom object. So I create a tree, and you can now iterate through the tree. I create a try, you can now iterate through the try. Like, I don't even know if those data structures support iteration, to be honest. Which brings us almost to the end. So we got generators, so the generators are a way of saying, I'm going to pause the function here, return you a value when you call next. But if you call next again, we're going to resume execution, go back. So this is like, you can see how this works. It starts at 0, and then the next time you call, well, that's an infinite loop, right? So you can keep calling it as much as you want. You'll get new values every time. And in particular, generators return iterators, right? Because they have that next method. So if you have that natural numbers function from the last slide, you can iterate over it. You get an infinite loop of natural numbers. And you can create iterators really easily, just like this. You say yield 5. So now you can iterate over that object, and you get 5 every time. What's really crazy here is that, it's not just for collections and just for like functional sequences. Generators are actually like shallow coroutines, meaning you can exit the function and come back in. And this is demonstrated fairly clearly, I think, by this. Right? So the function gets executed when you call it, but it's like paused. Nothing happens yet. You call next, it goes up to the yield. And so the console logs A. You call next again, it goes up to the next yield, B. Next, C. Next, it throws a stop iteration, which just says we got no more yields left for you. And what this means, right, this might remind you of something, is we'd like to be able to exit functions and come back to them when something's ready, like say an asynchronous callback. And you can actually do that now. So there's a library called Task.js that actually works in Firefox today that lets you do this. You say yield on something that's async, and when that data is ready, it'll come back. And now you don't have to be passing errors up chains and so on and so forth. You can just use a cache. You can use loops with asynchronous functions. You can actually use normal control flows instead of cobbling together a bunch of callbacks that don't say what you mean, just to do asynchronicity. All right, and the last piece of magic is proxies. Proxies, this is all I've got. They have a bunch of handlers. So what this means is that you can intercept any of these operations. So you can create magical objects that do whatever you want when somebody defines a property on them, or deletes a property on them, or checks if they have a property, whatever. And this is the syntax for it. So those are the most exciting features to me. And just to conclude, like, what's the idea here? Why should you care? Well, it's the future of JavaScript. It's important, right? You should be keeping up on this just like as a matter of professional pride. So if you're really interested, you should follow ES Discuss. You should stay tuned on this website that I put up, which has these slides and the version of them I had that was like 70 minutes, so less abridged. If you want to be really adventurous, use a transpiler, right? Like there's Tracer and TypeScript has some of these features where you can actually use ES6 features that just compile down to ES5. And the moral is, right, we need to skate where the puck will be. We want the web to be successful, we want JavaScript to be successful, and to do that, we need to not stagnate. So, that's it.